Good morning. So, here to talk to you today about Hyperlaunch, which is a project Daniel and I have been working on for some time, and hopefully quite a few of you are familiar with this. You may know it by a slightly different name or our previous work under the banner of DomB, but today it's Hyperlaunch. So Hyperlaunch is a major new feature that we started on in 2018, I think. And so what we're going to do today is we're going to talk about the motivation that set us off in this direction, the plan that we put together to deliver this to you guys, the things that have been contributing to Hyperlaunch along the way, where it is right now, and what it will be doing for you, hopefully with you in the future. So our aim was a request from our project sponsor to look at building a way of running Xen without the all-powerful DOM0, which has been a long-standing objective for Xen, and to make sure that the work that we did was suitable for integration into the upstream Xen project hypervisor, so that everybody could be using and benefiting from the same technology, sharing in that, and rather than carrying a downstream series of patches and a one-off thing that is not sustainable. So as a consequence of this rather simple-sounding request to deprivilege DOM0, we discovered that this has many consequences. We built a prototype to validate this approach, and that was described in last year's DomB presentation. A bunch of the technical work to understand what it takes to run a system that way was identified, and as a consequence, we undertook an effort to constrain the bounds of how big this project would become, and with a patch series of 40 or 50 different patches, which is a bit big to turn up to XenDevel and ask somebody to review and merge and iterate on, we switched our focus to engaging early with the Xen community to put together the design, gather requirements for other people who want this type of feature and behavior, and building consensus behind the direction that we're taking. So there was design sessions at the previous Xen Summit. There's engagement on the Xen community call. After the amount of engagement there was on the Xen community call, a Xen project working group was found so that we could have an entire call dedicated to talking about this, along with the group of people who were interested, with different requirements from different stakeholders. And as a consequence, we then went and wrote some design documentation, and several rounds of design documentation later, we were mentioned in the project announcement for the Xen 4.15 release, even though we're not yet merged or in fact complete. We're still working on this project, but yeah, we were announced, which was very nice to see, and the register picked that up. And as a consequence of that, I think we're now talking to you here with our keynote. So I hope this is interesting. So Daniel.
Yeah, so the plan. So at the beginning of this, right, we were looking at how do we redistribute DOM0's responsibilities, so that we could change how Xen itself could start and give us this disaggregated system as part of startup, with all the domains coming up at the same time. So one of the things we wanted to do in this was we wanted to retain the capability or compatibility of so that people could still have their DOM0 systems if they wanted to configure it, just have that classic way of starting Xen. And then on top of it, we wanted to utilize, extend, and integrate all of the previous work that's been done to kind of help either facilitate disaggregation or facilitate the communication of information throughout the system. So I'm not going to hit all of these, but these are the top technologies within capabilities within Xen that we are focused on. And then if we absolutely have to, then we would introduce new functionalities and ensure that it's all done in where it winds up basically in /common inside the tree. So that way all supported hardware architectures for Xen could then have the Hyperlaunch capability. Now, moving on, how do we get there? So just a quick recap of how do we get to a Hyperlaunch. So when Xen first started, it only had a DOM0 and the drivers were in the hypervisor. Eventually this was there were papers published on this, and some preliminary work was done to kind of start disaggregating Xen. But as some of this work was done, it just disaggregated some things into DOM0 or a couple of initial domains. There's, like we said, there's been a lot of research. There's some initial stuff looking at how to move device drivers out. Then there's the SVP and the Zor paper, which basically was focused on how do you completely break up a system. And then you've had efforts such as Xen Client, OpenXT, and Cubes to kind of accomplish those things in a deliverable package. So now moving on, we get to the first real big disaggregation that happened within Xen, which is the late hardware domain. This capability was submitted by Daniel DeGraff in 2014. And to really leverage it to its maximum capability, you could use the Flask system to help control what domains got what permissions. And this allowed you to separate what owned hardware, the physical hardware, from what was managing the system or the control domain. And so now you have this somewhat solid split, real solid disaggregation happening within Xen at this point, giving you the hardware domain and giving you the control domain. From there, moving on, go ahead.
So the more recent effort towards removing DOM0 from the system has been engaged in the Xen on ARM community, where there's a focus on accelerating the boot time of Xen on small embedded systems, where the time it takes to launch DOM0, bring up the tool stack, and then boot your workload containing guest domains was a competitive obstacle for Xen. So you can see Stefano Stabolini's keynote presentation at the Xen Summit in 2019, and also at the Embedded Linux conference, where describing the work where the ability for Xen to construct multiple domains at host boot was integrated, and it enables deploying Xen as a static partitioning hypervisor. And the structure of this is a good fit for what Daniel and I are looking to do for Hyperlaunch, in that it's a basic skeleton demonstrating that guests can be launched this way, and the use of device tree as the way of passing configuration information into the hypervisor for it to be able to build things is also of interest. So we started on the DomB project proposal posted in 2018, and we're soliciting community input, which gave us a number of different things to think about, and a reason to go away, do some design, and then come back with longer documents, and try and understand the different pieces that are involved in bringing up a full Xen system on x86, as well as ARM, and motivated the development of the prototype, which looked at how do you build a hardware domain as part of system boot, so you don't have the fully powerful DOM0 with the control domain permissions, and yet you still have a system that's functioning. And it identified other parts of the development that were going to be a challenge. It was also encountered by the DOM0less folks, where in order to bring up guest domains with device drivers, PV device drivers, there's a sequencing that's going to be required. So one of the things that we developed in the DomB project was the concept of a boot domain for running a workload outside of the hypervisor before the rest of the system starts, in order to enable additional work to be done and tailoring for the use case. We'll mention that later. So at this point, I think Daniel and I are rather proud of the fact that we've produced the heftiest design documents ever submitted to for inclusion in the Xen mailing list, and we're very grateful to those brave souls who've actually made their way through it and provided feedback to us. We would encourage you all to do the same thing. The documents version 4 are out on the list, along with the first patch series, which Daniel talked about in the domain rules for XSM talk yesterday. So that's a patch series where, because the DomB project is focused on disaggregating and removing functionality from DOM0 to distribute it to other domains, there's more granular access control required for those domains. And this is the first piece of work, hopefully, to go into Xen in support of this, as part of the piece-by-piece breakdown of the large piece of work that the DomB will into smaller, more manageable and easier to reason about individual patch series, building in that direction. We've also got the code for the prototype published and available on GitHub. You can have a look. There's a very fast port of that done to a recent version of staging, which is not quite tested yet, but that's going to be the base for our onward development as we're investigating. So this is rather intimidating table of comparison between different hypervisor systems. There's the classic DOM0 here, comparison with KVM. There's Xen with the late hardware domain, the Jailhouse hypervisor, which was a competitor for the Xen on ARM DOM0less work. And then there's also, the description here of Xen when you're using DOM0less. And finally, the Hyperlaunch in two different configurations. Hyperlaunch static, where the focus is on static partitioning. So in this configuration, you don't boot with a control domain, at which point you have statically assigned your resources to VMs, or the alternative configuration, Hyperlaunch dynamic, where you do choose to use a control domain. That comes with the flexibility of being able to reassign resources, but it's not strictly considered to be static partitioning. So you can boot either way based on the config that you provide. And the one thing that may have caught your eye is our little rocket here is actually no longer in the top right-hand corner, is actually shifted down here to the bottom with the cloud there. And I know you're thinking this is a description of launch, but actually, as Elon has taught us, this is a rocket actually landing here, and we have every intention of landing Hyperlaunch in Xen with your help. So the major takeaway from this slide, I would recommend studying these aspects of Hyperlaunch in the design document. But the key thing is that this really is going to enable a use of Xen and use of a hypervisor in a way that we don't think is available in any other general purpose hypervisor today, and has significant benefits to what you can do with a virtualized system, which we'll cover. Daniel?
Yep. And so, in order to achieve some of this, as Christopher kind of alluded to here, we needed to to categorize all of the roles that DomB had in the Xen system today. So if you saw my talk yesterday, which is linked here, this is kind of how we broke everything down. It's just at a top level, right? We didn't want to get into a fine grain. This is a coarse grain breakdown of the roles that DomB provides for the system today. And so you've got your platform management, where you're managing the host, things like power management, EFI configurations, boot configurations, these things about the host that are not specifically making management operations for specific domains. You have domains themselves for that, in the management of those through both the construction and destruction of them, as well as the lifecycle management of domains once they've been constructed and before they ultimately get deconstructed. Then you have your virtual hardware that you're providing to the guests. You have emulation of those, as well as providing back-end PV drivers. And finally, there's the management of the physical hardware itself. It's provisioning and deprovisioning it from the hypervisor so that it can be made available for domains. And then there's the lifecycle management of it once it has been provisioned, for assigning to a domain, unassigning to a domain, resetting it before you reassign it a second time, if that were to be the case. And so that takes you through the roles that we envision that could be disaggregated during system launch. So now moving on, we get to the structure of the launch itself. So the goal here was to adhere to the principles of least privilege. So we wanted the hypervisor to take on the role of doing the domain construction. And so it would be responsible for setting up, based on material provided to it at boot, the construction of those domains and assigning the permissions and getting the initial representation of them created in memory. All of this would come from the bootloader, including a manifest of all the domains inside of a device tree format, along with all the kernels necessary to and RAM disks necessary for each of the VMs that you've defined. Some of the options here that we were looking at was actually being able to reuse kernels, so that way you don't have to have a kernel per domain if you can actually have the same kernel. Those kinds of flexibilities were being built into it. And then there are cases, and it may be more than not, we'll figure that out as we start to get further along here, is the option to have a boot domain that kind of is an intermediate deprivilege of final configuration of the VMs that were instantiated by the hypervisor. So the idea here is that, again, following least privilege, this boot domain would only have the necessary privileges or roles, in this case, necessary to configure the VMs, and if necessary, unpause the domains in a sequenced order before returning back to the hypervisor. Once the boot domain is complete, it would then, like I said, return back to the hypervisor, and the hypervisor would clean up after the boot domain, look at any domains that are left in a pause state, unpause those, and then allow the system to begin to run. So the boot domain itself, as I kind of highlighted here, we wanted to offload some of the assumptions from the DOM0 architecture. This is one of those consequences from trying to break up DOM0. There are certain assumptions that DOM0 is up and running and able to set up certain information, and certain services are available, such as XenStore, for you to create and launch additional domains. So in order to deal with that, this is where the boot domain concept comes from. So as we said, the key structure here is the hypervisor does the construction, the boot domain handles your tool stack operations to finish configuration and the sequencing of the start. And the idea here is that we do this in a manageable way to provide flexibility and to be adapted to the different use cases that we envisioned, as well as those that we've collected from additional people. Okay, now moving on. So this is where we get into the use case flexibility. Now that DOM0's responsibilities are now redistributed, and the system start itself has now been restructured, you can now do a lot of different things with the same hypervisor binary. We're not even saying you have to recompile. You get this in a single binary instance. You can reconfigure the system to launch in different ways as you need it to. So as we said, you can sit there and do your classic DOM0 startup. And this, with the one additional thing you gain with this, is you can still do a classic DOM0, but then you can also launch some guest domains at hostboot at the same time. So you may want to still run your all-pros DOM0, but you still want some of the fast boot properties of getting more domains going as the system comes up. The boot domain enables TrenchBoot to build a TrenchBoot boot domain that can be used to start your DOM0. This would then enable you to do a measured launch through the hypervisor and not have to introduce all of the code and measurement and TPM interfacing and all this stuff in the hypervisor directly, and know how to measure every device and everything that you might want to measure as part of the launch. This gives you the flexibility that you can have a configurable boot domain to take your measurements and start your system. So this is very in line with what OpenXT is concerned with. And then you can get into some very interesting statically partitioned embedded systems where you have no DOM0, you have no creation, construction, deconstruction privilege. So you actually wind up with a system that functions similarly to the compile time partitioned hypervisors like Acorn and SEL4, right? You now have a system that you cannot create any new domains. So that provides some very hard partitioned systems solutions. Then you can move on to like dynamic partitioning systems where, again, we can isolate the hardware domain, we can split the system up, you can have dedicated Xen stores, dedicated VTPMs, and have all of this isolation. So moving on, we get into the benefits of all of this. So from a security standpoint, we've reduced the permissions for the boot domain. We've provided commonality and correctness, so the same logic is being used across all Xen deployments, both for or specifically in the domain construction. And if you reuse the same boot domain, you wind up getting the same way the domain or same tool stack configuring these domains. Performance, obviously, if we can start more domains at boot time, that gets you to your target runtime configuration much faster. From a compatibility standpoint, again, you can reuse your familiar tools for your use case customized boot domains. You don't need to adopt a brand new tool set to use this. You can put XL right inside of a boot domain and use a bash script to configure if you wanted to. If that's what your use case wants, that's what you can do. From a capability standpoint, we can start doing some very advanced configurations, as I said. One of the more interesting ones is doing a PCI pass-through, where the tool stack runs in a separate domain from the hardware management. And so this brings you to the fact that this leads to adaptability, allowing policy-based dynamic assignment of hardware by the boot domain. So now we can move into the use cases.
So we're interested in evangelizing this to the other communities within the Xen community. So for what Hyperlaunch and the significance of it for the embedded x86 NARM systems, our sponsor, our project sponsor, has embedded x86 systems. And what this Hyperlaunch enables you to do is, the goal of the project: remove the all-powerful DOM0 from the system for those who are focused on security or safety requirements. That's a benefit. Isolating hardware into a dedicated hardware domain that can be simpler for reasoning about what the contents of the software that's managing your hardware, what device drivers, what components you need in there, while isolating that from the other components on your system. We can flexibly assign resources to VMs, so your boot domain can do dynamic discovery of what is running on the system if you want to adapt to the environment you find that you're booting on, if you have a situation with different hardware but the same system image. As Daniel mentioned, we're looking at enabling PCI pass-through assigned to VMs at the time of host boot, so hopefully faster and earlier than you are currently able to do. And combining this with CPU core pinning, I think you've got an interesting novel configuration, different than what you would have with a current Xen system. We'd also like to reach out to the unikernel projects that use Xen, in particular, with breaking down and redistributing the functionality that's currently present in DOM0. We should be able to foster the use of small unikernel domains started at host boot to run as platform service VMs. It would be interesting. Firewall, as used in the Mirage project for cubes, would be a good example. So hopefully the folks in these projects are taking a look at Hyperlaunch and seeing what it will enable for them. For those using unikernel systems for security purposes, the fact that you can start the unikernels at host boot should mean that the TCB for those is reduced, and you should be able to boot even faster. So if you want to test your unikernels with the full hypervisor binary, you should be able to have a faster CI loop, since you can start these at host boot now.
Okay, so we're going to move to the next couple real quick. So for edge virtualization, obviously, again, disaggregation of the host boot gives you, separation of your tool stack and your hardware domain. You can do isolated network and storage domains, VTPM, the VTPM architecture, and be able to enable, DRTM measurements in the boot domain. We've kind of gone over that. Moving on to the next scenario would be the server and cloud. So here you have, your cloud providers and your server solutions. Some of the, again, you can get the DRTM and remote attestation for health on these. One of the capabilities we really haven't talked too much about that's coming in the design sessions and would be applicable would be the recovery domain and crash environments for rapid recovery from failure. Again, like we said, preserves investments in tool stacks and management stacks, so that they'll be able to continue to use what you have today, and be able to. One of the benefits is through rapid provisioning, you can bring your customers' VMs up as you're bringing new systems online. And with that, we'll move on to.
So we would like to encourage you to attend our design session at this event. We were very interested in hearing what you think you may be able to use Hyperlaunch for, and what the requirements you have as part of that use case would be, to make sure that we can incorporate that in our design. We've got patch series posted, we've got code posted. We're going to be continuing to iterate on new patch series to be posted based on the stuff we learned at building the prototype. You can talk to us on the Xen project community call or our working group, which the announcements for when we meet are posted on Advance on Xen Devel. We're also engaging in other projects that are external to Xen as we find that we need to. In particular, the Linaro System Device Tree project is doing interesting work, so we're participating there. And thank you to Starlab for sponsoring Daniel and I to perform this work, and to the Xen community, many members who've been involved and provided fantastic input and feedback, very helpful, and to the people who have built functionality into Xen that we're able to leverage in pursuit of this project. So thank you. We've got some additional references for those who are interested in finding out a bit more in the slide deck that's posted. And with that, I think we're ready to launch.
We're counting down.
Awesome. Thanks, guys.
Thank you.